Okay, so today is going to be the first basic lesson for trig. So what we're going to talk about today is we're going to talk about some basic vocabulary and then some basic items that kind of start trig off that you have to know in order to do trig in general. Whoops. Okay, so first thing we need to talk about is some basic vocabulary. The vocabulary must be memorized. Okay, you will have a quiz on the vocab next week. You need your notebooks out. I want you to write this down in your notebooks on top of it already being in your calculator. You're going to need your notebooks every day. Trig requires quite a bit of drawing. We're going to be drawing things on a daily basis, so you have to have it with you. If you don't have your notebook, go in the back of the room, get a piece of paper, get it into your binder after, or tape it into your notebook after. Okay, so the first thing we're going to talk about is something called standard position. Okay, standard position is when you have an angle. And when we graph angles in trig, we graph angles on a coordinate plane. So that means XY axis, right? So standard form is when you take that angle, you graph it on the XY axis. The vertex is going to be at the origin, and the initial ray is going to be along the x-axis. So let's take a look at what that looks like. Okay, so what standard position looks like? Again, you're going to have the vertex at the origin, the initial ray is going to be along the x-axis, and we wind up doing rotation. So what I mean by initial ray, what's initial mean? Start, okay? So this would be your initial ray. What's a vertex? Describe a vertex. You all took geometry, right? What's a vertex? What part of the angle is the vertex? Where it comes to a point. Okay, so here's my vertex, right? Where it comes to a point. Vertex is at the origin. Okay, this is the vertex. Everyone should be drawing this. Everyone. You are going to do that, yes. You don't have to do that at this very moment. You got to follow along with what we're doing. Okay? And on this quiz, pictures will be required, so you will have to draw this out. Okay? So we've got our vertex, we've got our initial ray. This ray is what we call our terminal ray. Give me something in real life that we refer to as terminal. What else? Terminal. Terminal illness. What happens when you have a terminal illness? You die. Okay, so if you have a terminal illness, you die. What happens to my angle at the terminal ray? It dies. It ends, right? Okay, so my terminal ray is where my angle ends. Got it? The other thing that you need to have is your direction of rotation. Angles can go two ways. They can go clockwise or they can go counterclockwise. Okay? So to show your direction of rotation, you need to show which way you're going. So that's how you show that, okay? If we go counterclockwise, it represents a positive rotation. So if counterclockwise is a positive rotation, what's clockwise? Negative. All right, so now we have initial ray, we have terminal ray, we have vertex, we have direction of rotation. And again, this angle is in what position? Standard position. And what does standard position mean again? Good. The vertex is at the origin and the initial ray goes along the x-axis. Okay? So, vertex is at the origin, initial ray goes along the x-axis. That's standard position. 9 times out of 10, we will be drawing angles in standard position. God bless you. Okay, so we talked about standard position. We talked about positive and negative rotations and which way they go, right? Co-terminal angles. Co-terminal angles are very important. Okay, we'll talk about how we find coterminal angles a little bit later on, but you need to see what a coterminal angle is. All right, I'm going to erase all this stuff. It's just messy. All right, so let's say I have an angle in standard position. Okay, like this. A coterminal angle is any two angles. Coterminal angles are any two angles drawn in standard position. So again, their initial ray is where? On the x-axis, vertex at the origin. They have to share the same terminal ray. Okay, so that's the requirement. Same initial ray, same terminal ray. So how do we get a different angle with the same initial and the same terminal? Any ideas? Let's say that this is 75 degrees. Okay? I want an angle, same initial, same terminal. Is that the only angle that I can create with that initial and that terminal? No. How else can I create one? Sure. I can have this angle here, same initial, same terminal, right? But what is this angle? Which means it's a negative angle, right? So this isn't, it's a negative angle. It's clockwise, so it's a negative angle, okay? So that's a coterminal angle, going the other direction. What else would be a coterminal angle? What if I did this? Did I start in the same place? Did I end in the same place? How many times did I go around? One and then an extra 75. So 360 plus an extra 75. What's 360 plus 75? Calculator's in front of you. 360 plus 75. Okay, so 435 degrees would be coterminal. Okay. Okay, who thinks they can find me what that negative angle would have been? Think logically. If this much is 75, this much right here is 75, how can I figure out what this angle is? Subtract 360 from 75. Good. What's 75 minus 360? Negative 285. Good. So this is negative 285 degrees. Okay? So those are all coterminal angles simply because they share the same initial and the same terminal. Are they the same angle? No, absolutely not. Okay? So same initial, same terminal is coterminal. And we have ways of finding out what those angles are. You guys okay with that? So on this quiz, vocab quiz that you'll have at some point next week, you're going to have to draw me a picture of what two coterminal angles would look like. And they better include angle values. Okay? Notice every single one of these has a direction of rotation. That's very important because if you don't put a direction of rotation, how would you know if it's positive or negative? Would you? No. Okay? All right. The next thing we need to talk about is something called a reference angle. Okay? Reference angles are going to be hugely important when we get further on in trig. You have absolutely got to know how to find reference angles. We're going to go very in-depth into reference angles over the next 2 days. Right now, we're just going to get a basic look at where a reference angle is and how we find it. Okay? So, a reference angle is a positive acute angle. Acute, what's that mean? Less than 90. Okay? So it's a positive acute angle formed by the terminal ray, so the end of the angle, the terminal ray, and the x-axis. And it's the closest x-axis. We're not going to make some weird roundabout rotation to get to an x-axis. It's going to be very close to it. Okay, so let's see what that looks like. All right, so we're going to look at a couple of different ones here. Let's say I have this angle here. Okay. My reference angle, again, is the acute angle created by the terminal ray and the closest x-axis. Okay. So this right here is my reference angle. It's created by the terminal ray terminal ray and the closest x-axis. There's my reference angle. And we're going to find out how to algebraically determine what reference angles are as well. Okay, you guys all right with that? Reference angle. RA is reference angle. Okay, so let's say I had this angle. Okay, my reference angle, again, terminal ray, closest x-axis, right? So here's my reference angle. Terminal ray, closest x-axis. You okay with that? One more. Initial ray. Oops, terminal ray. Oh, that's ugly, isn't it? Here's my angle. Where's the reference angle? Yep, right here. Does it work the same way for negative rotations? Sure. Okay. So if I had this as my rotation, what's my reference angle? It's still right here. It's its own reference angle in this case. Okay. If I had negative rotation, looks like this, where's my reference angle? Right here. All right, so it doesn't matter if you're going positive, negative direction, it's still going to be that terminal ray with the x-axis. Got it? Good? Okie dokie. Okay, so again, you're going to have a quiz on vocab words. That'll be sometime next week. Okay, you have to know them. You have to know what these things are. All right, so on the next page, I just have some basic information for you. Okay, your initial ray, again, right here. Your terminal ray. Okay, and that's in what position? Standard position. Here's your reference angle. Okay. What does that 1 stand for? Quadrant. Quadrant 1, quadrant 2, 3, and 4. Okay, 1, 2, 3, 4. Counterclockwise. Okay. ASTC we'll talk about a little bit later on. It stands for All Students Take Calculus. And we'll get there in a couple of days, but that's going to be very important for us as well. All right. You guys feeling okay so far? This is totally different from anything we've done all year, right? Yeah. Okay, so let's do some practice. Answer the following questions by drawing a rotation diagram and identify the quadrant the terminal ray falls in. So, again, notebooks are going to be very important. You're going to be doing a ton of drawing, okay? So 145 degrees, that's the one we're going to start with. By the way, has anybody ever seen this symbol before? Yeah, theta. It's a Greek letter, theta. Okay. We use theta as a variable, like x. Okay. It represents an angle in this case. Okay. In almost every case. All right. So theta is what we're going to use instead of x, y, z. We're going to start using our Greek letters for trig. So you have to get very used to that. Theta can be found in your pi key next to the e. See it there? All right, so 145 degrees. We're going to draw the rotation diagram. These are all going to be in standard position. Okay, you're going to draw a separate picture for every single one of these. They can be small, they don't have to be big. Every single one of them is going to be labeled. Since you're doing this in your notebook, make sure that you write down what page this is on. Okay. So when we're talking about rotation, the first thing you guys have to be very clear on is what my rotations are. Okay, how much we're rotating at specific parts of the graph. So if I'm on the x-axis, again, what position? Standard position. Have I moved? How much have I rotated? 0 degrees. Good. So on that x-axis, we're 0 degrees. Okay, going up to the y-axis. How much have I rotated? 90 degrees. Back down to the y, or to the x, 180 degrees. Good. Negative y, 270, and then back up, 360. Okay, so quick way to remember this. Well, it's 9 times 1, or 9 times 0, 0. 9 times 2, 9 times 1, I'm sorry, I just skipped, I'm skipping numbers, aren't I? 9 times 0 is 0, 9 times 1 is 9, so 90. 9 times 2 is 18, so 180. 9 times 3 is 9 times 4, 9 times 5. So this is going to be 450. 9 times 6, so 540. 9 times 7, 630. 9 times 8, so 720. So do you see how we're finding those angle rotations? So it gets very, very quickly if you can remember them in multiples of 9. Okay? All right, so if I want 145 degrees, I know I'm going to be between my y-axis and my negative x, right? So 145, we could say, I don't know, about here. Nope. We're not using compasses. It doesn't have to be perfect. It's just a general idea. What do I need? I need the arrow of rotation, so I know which way I'm rotating. And I need to write down what it is. Theta equals 145 degrees. Okay, so I need to see the direction of rotation, and I want the angle labeled. Without the direction of rotation, I don't know if you're dealing with a positive or negative, so it has to be there. No, we're going to get there. Okay, so what quadrant is that in? 2. So she asked where would my reference angle be? My reference angle would be right here. And we're going to talk quite a bit in depth of how we find reference angles. But if we think logically, I know that this whole thing is how many degrees? 180. Okay, it's 180 degrees. So if this much is 145, how can I determine what this much is? Yeah, 180 minus 145, which would be what? 35 degrees. So my reference angle would be 35. And we're going to talk quite a bit in depth about that a little bit later on. Okay, so that's how you would find a reference angle. A lot of this is going to be common sense. Okay, if you know how much the whole piece is, how do you find a part of it? So we're going to be doing a lot of that. All right. Okay, so what's the next one? 320? Okay, so go ahead. I want you guys to go ahead and see if you can draw the rotation diagram and state the quadrant in which the terminal ray lies. Okay, so 320 degrees. Again, we're starting in what position? And what does standard position mean? Vertex is at the origin and initial ray is along the x-axis. So we know we go 0, 90, 180, 270, 360. So we're going to be between 270 and 360 for 320. So let's say we're about here. How do I show my direction of rotation? Clockwise or counterclockwise? Counterclockwise. So from here to here. Okay. And then make sure you label it. Theta equals 320 degrees. Where did the terminal ray terminate? In what quadrant did it terminate? 4. Please use Roman numerals. Feeling okay so far? Theta just means it's like x. It's the angle. It's a variable. That's all it is. Okay? All right. So let's try another one. What's the next one? 72? Okay, so go ahead and draw it, and we'll come back in just a second. All right, so initial ray. What quadrant am I going to be in? Yeah, let's say about here. Theta is 72 degrees. What angle, what quadrant is it in? 1. Where's the reference angle? Yeah, the reference angle is itself. right? Reference angle, if you have an angle in the first quadrant, the reference angle is the actual angle. Doing okay? All right. Next page. Let's get a little bit harder. We're going to try negative 210. We'll do that one together. All right, so we know our initial ray is going to be in the same spot, that standard position, vertex at the origin. If I'm doing a negative rotation, things switch up a little bit on me, okay? Because what direction am I rotating? Clockwise. So this is no longer applicable. This isn't 270 anymore, okay? What is it? Negative 90. And then this is negative 180, and this is negative, and this is negative. Okay, so we're working in the opposite direction now, so you have to adjust for that. Get away. Okay, so negative 210. Negative 210 is between negative 180 and negative 270. So we're going to be somewhere here. How do we show the rotation? Yep. Okay. So negative 210 degrees. Reference angle? Theta. If you want to, theta equals, that's fine. The reference angle for that would be right here. Yeah. And we're going to do a lot of work with reference angles, okay? I'm glad you guys are understanding where they are. That's very important. Okay, good. So I want you to try the next few, and then we'll come back over them in a minute. Okay, first one, 250 degrees. My initial ray, where's my terminal ray going to be? Quadrant 3. 250 is going to be before 270, so it's going to be about here. Rotation is going this way. Hey, where's the reference angle for that? Right where? Yeah, it's right here. Okay, always back to the x-axis. Okay, 310, negative 310. What quadrant am I going to be in? First quadrant, good. So we're starting here. We're rotating this way. 310 is going to be about here. Okay, so we're rotating in the opposite direction. You okay with that? 460. Clear this out. Okay. 460. What winds up happening with 460? Yeah, you got to go around more than once, right? We know that this is 360 if we go all the way around once. Then this becomes 450. So 460 is going to be a little bit past that, right? So it looks like this. So all the way around and then some. Where would the reference angle be? Right here. Always backed onto the x-axis. Okay. All right, negative 400. Yes. Always have to mark the reference angle? No, only if they're asking for it, which they're not. She just, no. Okay, negative 400. Which way am I going? Clockwise. Okay. So we know this is negative 90, negative 180, negative 270, negative 360, negative 450. So where am I going to be? Yeah, quadrant 4. So we're going this direction. Okay. Think you guys got the hang of it? Okay, homework is page number 4. Okay. All of 1 is just asking you to do the rotation diagram. Open up to page number 4 in your packets. Oops. Yep, just page 4 today. Hold on. Okay, so number 1, I'm just asking for the rotation diagram. Make sure you label everything and tell what quadrant it terminates in. Number 2 wants you to draw the rotation diagram for each and then determine the reference angle. We haven't learned how to determine the reference angle. But what you're going to do is you're going to draw the rotation diagram, and then you're going to put in where the reference angle would be. And then we'll find out how to find it algebraically later on. So what I mean by that is 245, you guys know, is going to be where? Yeah, about here, right? So here's your rotation. What you're going to do is you're then going to show me where the reference angle would be. If you want to do it in another color, that would be awesome, because that would be a lot easier for you guys to understand. Colored pencils are a good thing to have. Okay, so that's what you're going to be doing for these. We're going to give the rotation diagram with the quadrant in which it terminates, and then just show me where that reference angle is going to be, and we will find out how to find it algebraically a little bit later on. All right, so just page 2 for homework tonight.